Hello, this is Mr. Waterman, and this is Lesson 6.5, Part B. We're now going to talk about side-angle side similarity. Second theorem we're learning in Lesson 6.5. So this theorem is a little more complicated than the side-side-side similarity theorem because now we are mixing angle information and proportional side information. And we're particular about which angle. Again, we're going to be using the included angle, just like on side angle side congruence in the last chapter. So the theorem here we have drawn triangle XYZ that is the same shape but a different size than triangle MNP. And so we know that angle X and angle M are congruent, and they're marked on the drawing as being so. And that side ZX, the ratio of side ZX to PM, these corresponding sides of the triangle, that the ratio of those sides is in proportion to the side XY and MN, these corresponding sides. And notice that we have the angles that are congruent are the included angles. That's the angle that is formed by the pair of sides that are in proportion. So if we have those angles congruent, the included angles congruent, and the two pairs of sides that form the angle in proportion, then the two triangles are similar. So let's use this in an example. So enlarging means to take an object and increase it, but you create a similar shape. In this case, it'd be a similar triangle to the original, but it's been scaled up by a certain scale factor. Alright, so we're going to enlarge triangle XYW, this outer triangle, XYW. Whoops, right here, the little guy. And we are going to enlarge it to the size of JHK, as shown. So, is triangle XYW similar to JHK? So, we are going to use side angle side similarity. To show that, or at least to make the comparison and make that decision. So first of all, let's see what information they've given to us. They gave us XW is 16, so that's this side down here is 16. Alright, and side JK, which actually corresponds to side XW, is 24. Alright, they've also given us these sides here, this side YW on the smaller triangle, and on the bigger one HK. They've given us the side lengths of those. So we have two pairs of sides, this pair and this pair, and we also have information on the included angles. So they told us that these are both 80 degrees, so these included angles are congruent. So let's set up the proportion and see if our sides, the corresponding sides, are in proportion. So first of all, I'm going to write down that these angles are congruent, though, just so that we can see that. Alright, so we have angle XWY is congruent to angle K. Okay, I used three letters over here because W, to just name it with one letter, is ambiguous. We're not sure if we're talking about the obtuse side of the angle over here or the acute side, so I went ahead and described it by using X and Y and W in the middle as the apex. Right? So, moving on, let's write ratios of the corresponding sides. So I'll use the small triangle, side from the small triangle compared to the corresponding side on the bigger triangle on the right. And then we will take the measures of these vertical sides. So I'm going to take YW, which is 18, and compare that with 27. Okay? So now all that remains to see if these are in proportion is to simplify these to their simplest term, to their lowest terms, and see if we get equivalent fractions. So we could take the cross products. These are kind of big numbers. So I'm going to go ahead and see if there's common factors. On this side over here, it looks like 8 goes into both of these. So this is going to simplify down to 2/3. All right. Over on this one, I've got 9 goes into this one 2 times. And 9 also goes into this one 3 times. So it does appear that these two triangles are in fact similar. So we can write triangle XYZ is similar to triangle JKH. And that concludes the second video.